In the next 10 minutes, you are going to learn everything you need to now about the stars in our Milky Way galaxy. As we gaze into the vast expanse of the cosmos, we are met with a sea of questions, shrouded in the mystery of the Milky Way galaxy. This celestial marvel is home to billions of stars, each with its own unique story. So, let's embark on a journey of discovery, a journey into the heart of our galaxy. Journey with us as we delve into the celestial world of the Milky Way galaxy. Imagine, if you will, the grandeur of our galaxy, the Milky Way, a colossal cosmic spectacle home to an estimated 200 billion stars, each with their own unique characteristics and mysteries. This majestic swirl of stars, dust and gas stretches over 100,000 light-years across, an expanse so vast it's difficult to truly comprehend. Within this immense celestial city, our solar system resides, a tiny speck amidst the grandeur. It's a fascinating place, the Milky Way, and it's filled with an array of wonders that continue to captivate scientists and stargazers alike. From its spiraling arms, densely packed with stars and cloaked in interstellar dust, to its bustling central core, a hive of stellar activity, the Milky Way is a testament to the beauty and complexity of the universe. Now let's venture closer and explore the fascinating phenomena of the stars within. Each star has a beginning, a story of its birth. Picture the universe as a vast dark expanse. Now imagine that within this expanse are pockets of cosmic dust and gas. These pockets are the birthplaces of stars, and our story begins here. These pockets, or clouds, are primarily composed of hydrogen, the simplest and most abundant element in the universe. Over time, gravity begins to pull this dust and gas together. This process is slow, taking millions of years, yet it's relentless. As more and more matter converges, the gravitational pull only grows stronger, attracting even more matter. This is the initial stage of a star's birth, known as a protostar. As the protostar continues to amass matter, the pressure and temperature at its core rise dramatically. It's here in this fiery heart that the magic happens. When the core temperature is high enough, it triggers nuclear fusion. Hydrogen atoms are compressed and fused together to form helium, releasing a tremendous amount of energy in the process. This energy pushes outward, counteracting the inward pull of gravity, and a delicate balance is achieved. This is the moment when a star is truly born, a brilliant sphere of plasma radiating energy into the cosmos. The star continues to burn, fueled by the nuclear fusion at its core, for millions or even billions of years. The light we see from stars is this energy reaching us across the vast distances of space. When you look up at the night sky, you're witnessing the end result of a process that started eons ago with a cloud of dust and gas. The birth of a star is a fascinating process, a testament to the incredible forces at work in our universe. It's a journey from simplicity to complexity, from dust and gas to a burning sphere of plasma, powered by the might of nuclear fusion. So the stars you see twinkling in the night sky had quite a spectacular beginning, didn't they? From their dramatic birth, stars embark on a journey of life much like us. Just as we grow from infants to adults, stars too follow a life cycle. However, their journey spans across billions of years and is dictated by their mass. Once a star is born, it enters a stage known as the main sequence. This is the longest phase of a star's life, much like our own adulthood, where it burns hydrogen to produce helium in its core, releasing energy in the process. This energy is what makes stars glow, illuminating the cosmic stage. Now, imagine a star as a cosmic balancing act. The gravity pulling everything inward and the energy from nuclear fusion pushing everything outward. As long as these two forces are in equilibrium, the star remains stable. However, as stars exhaust their hydrogen fuel, they start growing and get hotter, entering into the red giant phase. At this stage, they are like the elderly of the universe, swollen and bright, their outer layers expanding while their core contracts. If the star is of a similar size to our Sun, it will shed its outer layers, leaving behind a dense core known as a white dwarf. However, if the star is massive, its fate is far more dramatic. The gravitational pull becomes so intense that it triggers another round of nuclear fusion, resulting in a spectacular explosion known as a supernova. This mighty explosion scatters the elements formed within the star into the cosmos, contributing to the birth of new stars and galaxies. In the aftermath of a supernova, if the star was extremely massive, it may leave behind a neutron star, or even collapse under its own gravity to form a black hole, a region in space where gravity is so strong that not even light can escape. Each star, therefore, holds a tale of cosmic evolution. From their birth to their death, stars experience a journey of transformation and transmutation, playing an integral role in the cosmic cycle of creation and destruction. Like all living beings, stars too meet their end, but in a way most extraordinary. The death of stars is a celestial spectacle that unfolds over millions of years, a testament to the grandeur of the cosmos. Stars, much like us, live and die on a timescale that is determined by their mass. Smaller stars, those that are about half the size of our own sun, live a relatively long and peaceful life. They spend their days burning hydrogen into helium, a process that releases energy and causes them to shine. As they exhaust their hydrogen supply, these stars begin to cool and shrink, eventually becoming what we call white dwarfs. These celestial bodies, although no longer capable of nuclear fusion, continue to glow with residual heat for billions of years. However, the fate of larger stars is considerably more dramatic. These celestial giants, with masses many times that of our sun, live fast and die young. As their hydrogen supply dwindles, they begin to burn heavier elements, leading to a series of explosive reactions that cause the star to swell into a red giant. The star's core continues to collapse under its own gravity, triggering an even more violent reaction, a supernova. This is no ordinary explosion, but one that is so bright it can outshine an entire galaxy, even if only for a brief moment. What remains after this cataclysmic event is a dense core, which can take one of two forms. It can become a neutron star, an incredibly dense object with a diameter of just about 20 kilometers. Or if the star was massive enough, it collapses into a point of infinite density, a black hole. So while the death of a star may seem like a tragic event, it is actually a vital part of the cosmic life cycle. In their death lies the birth of new cosmic entities, a cycle of celestial life and death. So, the next time you gaze up at the night sky, remember that every twinkling star is on its own unique journey of life and death. Among this cosmic theater, there's one star that holds special significance for us, our sun. This luminous sphere of hot plasma, a mere speck in the universe, is an integral part of our everyday lives. It's not just a source of light and warmth, but the very cornerstone of life on our planet. The sun is a star, much like the billions of others we see twinkling in the night sky. Yet it's unique to us because of its proximity and the life-sustaining energy it provides. It is a medium-sized star belonging to the category of yellow dwarfs and is currently in the prime of its life, the main sequence stage. At this point in its life cycle, the sun is engaged in a constant nuclear fusion process, turning hydrogen into helium in its core. This process releases the energy that lights up our world. It's been doing so for about 4.5 billion years, and it's expected to continue for another 5 billion. When its hydrogen supply runs low, the sun will enter its next phase, swelling into a red giant and eventually shedding its outer layers. But worry not, this celestial drama is billions of years away. The sun, our very own star, is a perfect example of the marvels that exist within our Milky Way galaxy. Our journey through the Milky Way, through the life and death of stars, brings us to a profound understanding. We've traversed the birthplaces of stars, marveled at their radiant lives, and mourned their explosive demises. These celestial bodies, they're not just distant twinkling lights, they're the architects of the cosmos, the creators of elements that make up our very being. They're the ancient storytellers, their tales written in the language of light and gravity. We've seen how our own star, the sun, a relatively young star, plays a crucial role in our existence, fueling life on our planet. We've realized we are but a small part of a grander play, actors in the cosmic theater. Understanding our galaxy, its stars, their births, lives, and deaths gives us perspective, a sense of our place in the universe. In the grand cosmic dance of the stars, we find not just tales of the universe, but perhaps a reflection of our own existence.